Hello and welcome back to our Relational Algebra series. Today we are diving into a key operation that you'll find similar to what you see in programming languages. Yes, we're talking about the assignment operation in Relational Algebra. Let's get started. In relational algebra, just like in programming languages, we often need to store or assign values to variables. This allows us to reuse the results, work efficiently, and perform complex operations step by step. Let's first compare how assignment works in both contexts. In programming, you assign values like a is equal to 6 or g is equal to m. This means you are setting a variable. A variable in this case is this, a and g, on the left hand side equal to a value or expression on the right hand side. So the elements on the right hand side are the values and the elements on the left hand side are the variables. So a is a variable that's being assigned the value 6. G is a variable that's been assigned the value of m. Right? So right hand side is the value and left hand side is the variable. Similarly, in relational algebra, we assign values to relational variables. So on the left hand side, we have R1, which is a relational variable, right? Let's say we have a relational expression R2 union R3, right? And we wish to assign this query's output to a relation, say, R1. So we are assigning the output of this relation to the variable R1, right? Now this can be done using the assignment operator. The assignment operator can either be is equal to or it can be an arrow facing towards the left hand side. This means that we are assigning the result of R2 union R3 into the variable R1. Notice how, just like in programming, the assignment operation in relational algebra is also a binary operator. Why? Because it has two components. The left hand side, which is the relational variable, to which we are assigning the result of the expression or query, which is on the right hand side, right? So right hand side is the expression whose result is being assigned to the left hand side. So this is a binary operator. Now, when it comes to relational algebra, the relational variables on the left hand side we assign the values to can represent two types of relations. One is the permanent relation and the other one is the temporary relation. Permanent relations are the ones that are stored inside the database. Alright, permanent relations, that means permanent tables. These are the ones that are stored inside the database. And temporary relations, that is temporary tables, exist only during query execution. That is when certain query is being executed. Now, permanent relations or permanent tables are those that are physically stored inside your database. Like here, we have two tables here. One is the employees table and the other one is the new hire table, right? Now, let's say we are taking the union of the employees table and the new hires table, and the output of this union is being stored inside the employees table. That means when we are assigning a value or the output of this union inside the employees table, this employees table is being permanently modified. That is, we are making changes to the actual database, right? So when we are storing the output of this expression, that is employees union new hires, inside the original employees table, it is changing the employees table and it is also modifying the entire database. and thus assigning the values to original tables, the permanent original tables inside the database can be a bad idea because it could permanently change the tables while also changing the database. And thus we use the temporary relations or temporary tables. Temporary relations only exist for the duration of a query operation. Assigning values to a temporary relation allows you to store intermediate results without modifying the actual database. For example, here we are storing the union of employees and new hires inside a temporary relation named as temp, right? So here temp is just a temporary relation that is holding the result of this query, right? Now what could be the advantage of using temporary relation? First one is no permanent database change, which is very important. It does not make unintentional changes to the database. Next is efficiency. That is, they allow breaking down complex queries into manageable steps. And third is flexibility. You can reuse the intermediate result in multiple queries or expressions. Thus, temporary relations are very handy when you need to perform complex query operations without affecting the integrity of your database. That means you can treat them as scratchpad variables for relational data. Now let's take a quick example to demonstrate this. We have this query that we discussed while learning about the union operation in relational algebra. This is the entire query, right? Now it is fairly complex, but there are far more complex queries. In this case, we have a relation employees, right? Now in this relation, we are selecting. What are we selecting? We are selecting the rows where employment type is temporary and gender is male, right? And we are also selecting the rows where employee type is intern and gender is female, right? Out of this, we are only projecting the employee ID. We are projecting only one column, that is employee ID. And finally, we are taking the union of these two queries, right? Now, instead of writing such a huge query, we can assign parts of this query to a temporary relation or a temporary relational variable. For example, here we are assigning the first part of the query, that is this one, to a variable temp m. So this is a temporary relation, that is temp m. And this part of the query is being assigned to temporary relational variable, that is temp f, right? And then we are taking the union of both of these temporary relations and storing, that is assigning the output to this table temp. As simple as that. Thus, the assignment operation helps us to break down the query and reuse the temporary relations, making the process more efficient. So, the assignment operation in relational algebra is a powerful tool that helps us to store results, break down the queries, and handle complex data manipulations. But remember, when working with permanent relations, be very cautious as assignments can change your database permanently. On the other hand, temporary relations give you flexibility without affecting the actual database. So why is assignment operation important in relational algebra? First is reusability. It lets you store intermediate results and reuse them in subsequent queries. Step-by-step computation. You can break down complex queries into simpler, more understandable queries. And finally, simplification. It makes it easier to manage large and complicated queries by assigning results to variables instead of repeating expressions. So that was all for today's video. I hope you now have a clear understanding of how assignment works in relational algebra. If you found this video helpful, don't forget to like, subscribe and share with your friends. See you in the next one. Thank you so much for watching.